one of the things that I'm trying to do today is basically condense a talk that I've been giving for the last year to a whole bunch of people that tries to kind of do a comprehensive view of security, especially if you're either running an ISP or an enterprise network. And typically what I do is, it becomes security is sort of a chicken and an egg problem, because you have to understand some technologies before you even know what you might want to implement. And sometimes you're trying to figure out what to implement, but you don't really understand the technologies. And I've spent a lot of years trying to figure out how to best teach this. And so the way that I'm going to do it today is there's going to be 3 separate sessions. All 3 are going to be an hour and a half long. And the first third is going to be more or less describing what security technologies are, like how do they work, which is like S-key, SSH, IPsec, L2TP, list your favorite acronym. And just trying to give kind of a global overview of what they are and how they fit together. The second third is going to be an hour and a half spent on, all right, so now we sort of understand what all these technologies are, and if we look at our networks, how do we use them, and what do we do within our own architectures to have a more or less secure architecture. And then the very last third will be taking a look at actual configuration examples. Because one of the things that I've found, and let me tell you just a little bit about myself. I started in the networking world in 1988, and I worked for the National Institutes of Health, which is a major medical research facility in Bethesda, Maryland. And I had the luck of actually being their fiber person. So I designed their FTDI backbone, and we started using Cisco routers back in '88. Okay, so very early on. And for 5 years, designed and ran that network, the backbone. And then I ended up working for Cisco in 1993 until April of 2000. In 1996, I started looking very seriously at security, especially because the IPsec stuff was starting to get finished, at least the first round of it. And ended up doing a security initiative within Cisco, right, so that all the security pieces would get, or try to actually be somehow brought together. And as I started teaching security for the various customers, it became very clear to me that security means different things to a lot of people. You ask one person, they said, oh, it's encryption. You ask another person, they say, oh, it's filtering. And you ask another person, oh, it's their dial-up stuff, AAA. And the thing is that it's all of these. And the reason why security is hard, in my perspective, is because it touches all areas of the network, and there's so much to know. So it takes a long time to really have that comprehensive view of security and what it is in your networks. So anyway, today I will just try to hopefully, educate you in terms of what the right things are that you should think about to then come up with how to try and appropriately secure your networks. And remember, security is never absolute, right? You will never have anything such as absolute security. The best you can do is mitigate your risks. So before I actually begin, I just want to get a sense of how many of you are responsible for providing security in your networks? Okay. How many of you actually think you understand and know most of the security technologies out there? Okay. So I'm not surprised. How many of you have a security policy that you have read or in your companies? Raise them higher. Okay. It's better than most. That's about, maybe a fourth of the room. So let me just begin. So here's the sessions, all right? The first third is security technology details. But before we get to that, and this is why I asked the question about a security policy, all right? Policies are boring, right? Who cares about a policy? But the problem is that you might not even need some of these technologies, right? You might think that they're really cool and they're really fun and, hey, I can play with this stuff. But you know something? From a corporate point of view, your time might be spent doing something a lot more important. So the first thing that people have to do, and anybody who is even an operator, you can sit there and throw your hands out and say, policy stuff, that's for the higher ups. But the problem is that in this day and age, when companies start losing money because of security issues, sometimes they'll just take a scapegoat, and some of you may end up being scapegoats because you implemented something that may have not been part of a policy because maybe your corporation doesn't have a policy, but you may end up getting fired. So I am very adamant that everybody who is at all responsible in security go talk to your peers, to your higher ups, and basically say, we have to have a security policy, and get whoever the top level guy is to sign it. Create something on one piece of paper that maybe just shows that here's what I'm configuring because this is the policy, which basically says we're not going to encrypt anything and we're not going to authenticate anything. Have the CEO sign it, because that way, you know, if there's a security breach, you're not going to be held responsible. You have this piece of paper that said, hey, I just did what the policy dictated. So, you know, I really get discouraged when people just kind of blow off policies, because unless you know what kind of technology and what kind of security you actually need to put in place in your networks, what's the point? So you have to look through, you know, what are you trying to protect? So what's confidential, what resources are actually important to your corporation, and what are you trying to protect against? And, you know, what's becoming more and more prevalent is also regulatory stuff, right? So what kind of legal ramifications are there? And I just read something, I guess it was on the NANOG mailing list, I think, that there's one corporation that they trash their Radius accounting stuff every 30 days. And that's because the federal government, there was some issue where they wanted to see their logs. And so because of privacy reasons, I mean, that particular corporation, I guess, decided that, you know, they're only going to keep the logs around for 30 days. Right? But as a corporation, as an ISP, you have to make that decision, and it should be written down somewhere. So these are characteristics of a good security policy. I mean, you will see these slides later. They will be on the website. Currently, they're not. And I'm not going to walk through them. But, you know, this is something I want to point out, and I want people to seriously, you know, take these things into consideration. And again, why should you care, right? I mean, your job or reputation may be at stake. And since January, I mean, I've literally been around the globe. You know, I was in Sri Lanka in July, Taiwan in February. And I keep asking, like, how many of you have a corporate security policy? And there's very few. What really impressed me, the Indian government, they had a, you know, 160-page document. Then they also had like a 5-page document, because let's face it, you know, you want everybody to read it. I'm not going to read a 160-page document, but a 5-page document, probably, right? So you should have both, like one that's really comprehensive, and if there's any kind of legal issues at some point in time because of a breach, that you can show them this, you know, big fat document. But you also want something that's, and I prefer usually 2 or 3-pager, that every single person will read and understand. Okay, so it is important to have one. Very few people have them. So if we look at a typical network component, I don't care what kind of network you run, whether or not you're an enterprise person or whether or not you're a service provider, typically your networks can be broken up into these components. So you've got your main corporate component, your corporate network. So, you know, if you're an ISP and you're a medium or larger size ISP, you have some building, right, that's usually your core network. And then you might have other branch offices, and then you might have your remote access points where people maybe telecommute in, and you also have your customer networks. And so the things that you need to look at, what to secure, you need to look at all points, right? I mean, it's the weakest link, right, is your biggest problem. And so security has to be a comprehensive strategy. So you have to look at, okay, what routers do I control? What switches do I control? Where are my web servers? Where are my email servers? Where do I provide for authentication? And for all of these devices, you have to systematically look at who has control and access to these devices, communication to and from these devices, right? Is it authenticated? Is it to be kept confidential? Right? So there's a lot of legwork to be done before you actually start implementing any kind of technology. And so these are the elements that you need to consider, and I'm sure most of you are aware of these. I mean, authentication, authorization, data integrity, data origin authentication. A lot of people, when they talk about integrity, another issue with when people talk about security is people misuse terminology a lot. And so a lot of times people talk about integrity, and it's not integrity of the data or the packet. What they really are talking about is data origin authentication. You know, and for any of you that are familiar with IPsec, you know, that's another one. They talk about, oh, you get integrity. Well, what you get is data origin authentication. That's what they mean by integrity. So be very clear, you know, in terms of when you're defining something or trying to figure out what you're trying to protect against, you know, what your terminology actually means. So again, these questions are just more for reference because I don't want to spend too much time on policy. I will say, though, that I personally, you know, went through the process 2 years ago when I created my own little home network, and I started to play with a whole bunch of different devices and just, you know, making sure that I understand what kind of security needs are out there, even from a host basis, because I've usually been more of a network person. And it became very clear to me that you always have to do a risk assessment. And to me, it falls into two categories. One is, you know, am I going to go bankrupt or am I going to just be embarrassed? And that's where the trade-offs between technologies become very important, because there are some technologies where you can spend a lot of money trying to implement it. And the cost of actually implementing these technologies will far outweigh the cost of if you actually have a security breach in place. And so it is very important for people to do a risk analysis and to see where your money is better spent. And again, these are just going to be more or less for reference for risk analyses. But when you look at what's important from an infrastructure point of view, okay, you have to have security controls in place. And when you look at devices, right, you have to figure out, okay, well, what kind of media am I using? Am I using wireless networks? Am I using fiber optics? Am I using a shared media, you know, Ethernet that are maybe still bridged, or am I using switches? The equipment location is important, as well as environmental safeguards. And with equipment location, I mean, we always used to laugh that, oh yeah, who's going to carry, you know, a big machine out? Yeah, ha. But I believe a couple of months ago in Australia, you know, there were people that were impersonating some repair people, and what they actually ended up doing is taking a mainframe out of the building with confidential information. So, you know, it's funny because it didn't happen to us, but it happens. So you do want to be somewhat careful, you know, and make sure that your physical controls and accesses are in place. The logical security controls are the ones that people are, you know, more or less familiar with and pay more attention to. And what these are, it's your console access, your remote, your logical terminal access. And I have to always correct myself because I'm so used to always saying, oh, I'm going to telnet into the router, which in this day and age is, you know, I really should get away from that because you should be SSHing into your routers or switches. But your logical security controls include not only your SSH access or your console access, it's also any other way that somebody can access your critical infrastructure devices. And two mechanisms that are very widely exploited are either through the web, right, HTTP, or SNMP. So you have to really carefully think about, you know, do you need that access and why? And there was something going on recently where people are starting to do some reconnaissance attacks on specific routers and looking to see whether or not they have HTTP servers enabled, because some equipment has vulnerabilities, right? So it's very important to disable these services or these mechanisms of access if you're not using them. You also have to look at system and data integrity, right? So we all understand firewalls, I'm sure, and then also the network services. And this is a very controversial issue, and especially for ISPs, because, you know, are you going to be the network police for all of your customers? And the answer is a resounding no. Okay, that is not your role. However, if there are some denial of service attacks happening and it's causing a huge headache, you have to put these filters in place so that the networks can still be available. Okay? It's a problem that cannot be resolved by just saying, nope, we'll never put in filters. Yep, we'll put in filters and we'll keep them in for 2 days. It's a moving target. So the best thing to do is just kind of work with your customers and kind of see what the better solution is. But ISPs are not the network police, because it breaks other applications as it's becoming clearer and clearer as more ISPs are putting these filters in place for specific ports, and it ends up breaking things. All right. One point I want to make is that no matter what, you will always have some kind of security incident. Okay? I don't care how big or small it will be, there's always something you need to deal with, and it is very important that you have procedures in place so you know how to deal with it. Because no matter what, whatever equipment you have, right, it's software. Software is written by somebody. Nobody's perfect. You may think you're perfect, Maybe you are. I doubt it. So the thing is that there's always going to be a software bug. Some bug is always going to be construed as a security vulnerability, because guess what? This vulnerability, somebody can get access to this equipment, or they can do some kind of damage that can bring down your network. You know what that is? That's a denial of service, because your network is unavailable. So you have to have certain procedures in place so that when vendors tell you that there's an issue, that you know how to test maybe this new software, because if you just listen to the vendor and, put in this new software version, I wouldn't want to work for you. You have to, I don't trust anybody, okay? And even a bug fix, okay, or a vulnerability fix can have issues. And so corporations should have some kind of procedures in place to test new versions of software before they deploy them. All right? And you might just have this thing in place that says, anything that's supposedly really critical and can bring our whole network down, well, then your NOC will, stay, 24 hours to test the software, run through all the tests, and then implement it. Whatever it is. Or you have some way of putting in that software, and then as soon as you see an issue, you backtrack it. But you have to be aware that incident handling has to be part of your known procedures for what you do. A lot of people just kind of wait to see when something happens, right, because they've never been hit by a security issue. Or they're like, oh, we're all proactive, we really keep track of everything, and nothing will happen to us. But the day that it happens, it could be disastrous. So just have something in place. And one of the biggest reasons to do this also is that you as network operators, right, you're going to be sitting there trying to put in filters in place. You might, need to shut down certain customers. Customers will sue the corporation. And again, it comes down to you don't want to get fired. Okay, so you want to have your management say, in case of a critical event, for 24 hours, the guys are the operators and, the NOC team members, or, the 5 big grand poobahs who, configure the routers, that they have the absolute right to do whatever they feel is necessary for the company. And that will save your butts. So, anyway, I keep stressing it. I think I've stressed it enough. So now, Crypto 101, fun stuff. How many of you understand what secret key and public key technology is? Okay, I'll go through them fairly quickly then. All right, so cryptography, it's not just used for confidentiality, right? Cryptography is used for authentication. It's used for data authentication, data integrity, and data confidentiality. So when people say, oh, are you using encryption, right? Typically what somebody's trying to say or ask is that, well, are you using, cryptography for confidentiality? But keep in mind that cryptography is actually used to also authenticate, provide data origin authentication and integrity of packets going from one place to another to make sure that nothing's been altered in transit. So what is public key encryption? Public key encryption, you basically use two keys. There's one key that's called a public key and the other one that's called a private key. Now, I think it makes sense that the private key should be kept private. Okay, nobody, and I mean nobody, should know the private key except for the entity that created it. But computing this key pair is pretty computationally expensive, right? So because there's mathematical, gobbledygook where certain things have to be, just precisely so, and I'll go through that in a minute actually for some. But it's usually more processor intensive than another mechanism. However, public key technology is very often used for data origin authentication. So this slide just shows how that would work, where basically, let's say that we have two routers, router A and B. So router A would create its public-private key pair, and then it would, in some way, okay, and this is always this, oh, it's trivial to do this, but you send the public key over to the other entity, so in this case, router B. And so to provide the data origin authentication, what router A would do is it would encrypt whatever data it's sending with its private key, and then router B would decrypt it with its public key. And because the assumption is that only router A knows the private key, right, you have therefore then provided data origin authentication. Now the problem comes in is that how do you actually know that router A sent its public key, right? How do you validate it? How do you verify it? And that is one of the biggest issues in security, and there's been a lot of hand waving, at least in the last 10 years, that, oh yeah, it's got to be done in a secure method. But then when you sit there and you run your networks, and in practical ways, you sit there and go, well, what is a secure method? What do you do? Do you call somebody up? Well, some devices did do that, where you're required to actually sit there on the telephone with somebody on one router and some, person on the other end with the other router, and then say, yep, here's the fingerprint, yep, I'm the one that sent it right now. That's not scalable. So anyway, so there's another common way to do cryptography, and that is secret key encryption. And so secret key encryption, you essentially use the same key on both sides. So both router A and router B would know a secret key, and then one router would encrypt the data and the other side would decrypt the data using the same key. And some of the algorithms that are used that use secret key encryption are like DES, triple DES, AES, and IDEA. So for those of you that might just see these acronyms, I mean, just trying to put some perspective in what the acronyms, whether or not they're public key or private key technology. So, but the scalability problem with secret key encryption is that usually people configure the shared secrets on two entities, right? That's not scalable either. I mean, you have 1,000 routers. What are you going to do? Configure these keys on them? That's not really very practical. So there's an algorithm called the Diffie-Hellman algorithm, and what it does is it uses a combination of public key technology to derive a shared secret. And this is a very simplified slide that essentially shows how this works. And so you have, let's say, two routers, right? What ends up happening is that router A creates two very large numbers, A and P. Both of these numbers are prime numbers, right? And they have specific characteristics. I don't remember exactly off the top of my hand what they are, but these really smart mathematical geniuses here, have come up with. All right, so if you have A and P, they're both prime numbers and they have certain characteristics, then it's very hard to guess what they are. And what ends up happening, both router A and router B then on their own also come up with another large prime number. So for router A it would be XA, and for router B it would be XB. And they go through this particular algorithm to create YA and YB. Right. Then they exchange YA and YB to each other, and they again go through this mathematical function and end up with the shared secret Z. So in essence, what Diffie-Hellman does is you can send some large numbers, right, in the clear to each other and end up with a shared secret that's only known to those two parties. Now the issue with this, though, is that Diffie-Hellman is subject to a man-in-the-middle attack. So what needs to happen is that Diffie-Hellman needs to be authenticated. So you need to use some cryptographic means to authenticate the numbers that you send across. So remember I showed just a couple minutes ago the slide where you can prove data origin authentication, right, with public key technology. This is basically what you use to send the values in the clear to the other side. Okay. But just remember that, I mean, the really important thing about security, and to me it's always the most essential element, is authentication. You know, what degree of trust do you have that somebody is who they say they are? Right? I mean, if I send you some kind of information and I'm encrypting it, what does it matter if nobody can sniff it on the wire when you are not really sure whether or not I'm the one that sent it or somebody else? So I'm one of these people that I don't really care that much about encryption for confidentiality on the wire. The most important thing for me is authentication. You know, being able to more or less trust that you are the one that, you know, I expect to send me the data. And that's always something that I look at when I look at, okay, you know, what do I need in terms of security? So another very fundamental concept that really needs to be understood for security is what is a hash function. And a hash function creates a hash. It's also called a message digest. They essentially mean the same thing. And what it is it takes some kind of arbitrary length input message and it produces a fixed length output. Okay, so I think most of you have at least heard, you know, of the MD5 algorithm or SHA algorithm. These are all hash functions. They're one way, they're irreversible. And MD5 produces a 128-bit output and SHA produces a 160-bit output. So, you know, a lot of times people try to figure out, well, which one should I use? I don't know, SHA is a little bit more computationally expensive, but some people think that MD5 may be more susceptible to some attacks. So a lot of people really, if they don't really know which one to use, recommend SHA-1. So if anybody has more data in terms of, you know, MD5 really, you know, has issues, you know, speak up, because I would love to know. But anything that I've read and people I've talked to, it's just kind of like a hand waving, like, well, we think that SHA-1 is more secure. So, okay, I threw this slide in there because there's times that I talk about certain technologies and how they work, specifically in IPsec. You know, and you hear about all this technology, and you know, you will hear quite a bit about HMAC, you know, HMAC SHA, HMAC MD5. And another thing that I find so funny about security is that you have to understand, like, the security in-depth little nitty-gritty details to actually configure security. I hate that. I think it's stupid. It's like understanding the Dijkstra algorithm, or, you know, really understanding it to configure your routing protocols. You know, and I'm hoping that vendors will get away from that, because I don't really care what SHA or MD5 or all these things are, but I have to make a decision whether or not to pick one or the other, right? I mean, that's a pet peeve of mine with security. But anyway, so exclusive OR, how many of you remember this from math way back when? Okay, cool. I'm not going to go over it. So look at this slide. I mean, it's pretty simple. It just means that you have, one string of bits the same size of the other string of bits, and, you come up with some answer, and that answer is reversible. So you can come up with the input again. So the reason that I brought that up was because when you do a keyed message authentication code, it's also basically a keyed message digest. A lot of hash functions are used with a specific key. Okay, you combine a shared secret with a hash function, and essentially that's what HMAC is. It's a keyed MAC. So the message, whatever data you're trying to send, okay, let's say it's a routing update. The message is broken down into n blocks of 512 bits. Then the shared secret key, which you've configured on both sides, is XORed, right, that function that I just showed you in the slide, is the XOR is applied with a specific array. And these arrays are well known. They're defined, okay? And then you end up with K1. And so that the shared secret is XORed a second time with another specific array to produce K2. All right, so this is just some pre-processing that's done. All right, and so when you're doing IPsec, I mean, this is basically what's used. So you have the standard itself. There's people that have come up with these arrays that you use. Okay, and so you have a message that you're going to be sending, and so you then XOR the message with one array, come up with the result, and then you take the shared secret key and you XOR it with another second array, and you come up with K2. Now you start the hashing process. So you then take the first block of the message and the result, K1, and you apply the MD5 algorithm to it, and you end up with hash 1. Then what you do is you take that hash 1 and you concatenate that with K2, and you end up, you apply the MD5 algorithm, and you end up with hash 2. And now, depending on how many blocks of messages you have, you end up continuously iterating the hash function by taking a block of message and the previous hash and applying the MD5 algorithm. All right, and then essentially once you get to the last block of message, you get your last hash, you end up with a string of bits. Remember that it's 128 bits for MD5 and 160 bits for SHA. And then depending on a specific algorithm like HMAC MD5 96, that means that you truncate to 96 bits. All right, I don't know how many of you care about this, but it might be interesting. So anyway, I figured I'd explain it. So keyed MD5 and keyed SHA is very often used in most algorithms, again, to provide more security, right? So then, all right, what are digital signatures all about? Because we hear about digital signatures. In my best experience, there's a lot of talk around it. There's not a lot of people that actually practically use them. And most of the reason why is because it relies on the public key infrastructure, right, a PKI. And I believe since 96 or 97, people there were really hot and heavy about being able to implement a PKI. But the problem is that nobody knows who to trust, right? I mean, do you trust the U.S. Post Office? I remember that was something that people wanted to do at one point in time. And you might trust your own corporation, but then again, how scalable is it? Right. So I believe that hopefully now, like most of the other security issues, have come to some kind of resolution that nobody can hand wave anymore about the PKI issue. So I am still optimistic that maybe in the next couple of years, people will come up with a credible and practical solution for how to actually enroll certificates in a secure manner, because that is the whole entire problem that still needs to be solved, is how do you bootstrap the entire system, right? And like here too, I don't remember if it's tomorrow night, or I think it's tomorrow night, the PGP key signing, right? I mean, people get in the room to say, yep, that's who he is, right? How do you do that with thousands of devices, right? So anyway, that's a big problem to be solved. But so what is a digital signature? It's basically a message that's appended to a packet. And it's used to provide the identity of the sender and integrity of the packet. And two common digital signature techniques are RSA and DSS. And how it works is that a sender uses its private key to sign a packet, and the receiver uses the public key to verify the signature. So I'll talk about digital signatures a little bit more later because, especially in route authentication, the problem is, and what I found, and I for years was also under the misconception, was that MD5 authentication is actually digital signature, but it's not. So it's basically you just append a hash, a message digest to a routing update. So, you know, how secure that is, you know, a little controversial, I think. And one of the things I'm going to bring out in the second session, just as something to think about, is that whether or not it makes more sense in the future to look at either using the MD5 authentication mechanisms that are either an extension or built into the routing protocols, or whether or not it makes more sense to beat up on the vendors and provide some mechanism to provide for IPsec authentication. Okay, I know that some vendors actually have made it fairly simple with doing BGP authentication using IPsec. And the thing is that getting new keys is a lot easier that way. I think a lot of implementations of MD5 authentication, the major issue is that, all right, so you've configured your key. What happens when you want to have a new key, maybe 2 months, 6 months down the line? Because you really should not have the same key for years and years on end. And then it becomes this problem of, well, you know, do the implementations actually support that, or is your routing going to be down for, you know, a couple of minutes or even longer while the new keys then get reestablished? So that's just something to think about if you haven't even implemented it. I'm a very strong proponent of doing some kind of route authentication. Whether or not you are going to start using IPsec or use the MD5 is still something that I think people should really look at from a practical point of view. All right, so as a summary, public key encryption, okay, is typically used for data origin authentication, and it's often combined with a hash function. So to do digital signatures. Secret key encryption is typically used for data confidentiality. And to do secret key encryption, it's usually computationally a lot less intensive. All right, public key technology, you take up a lot of CPU cycles when you're trying to determine what your private and public key pairs are. The Diffie-Hellman algorithm is very widely used to create a shared secret in an open environment. And let's see, hash functions, while they're easy to compute, used for data origin authentication and data integrity, and digital signatures use hash functions of public key cryptography. So, all right. So that's sort of the basics of how any kind of security technologies, they use one of these fundamentals, right? Either a public key technology, a symmetric key technology, or a hash function, or a combination of. So now, all right, in the real world, right, what do you use? And again, I'm going to talk about first authentication technologies because there's a slew of them, and there's a number of trade-offs. And then what do you do if you're looking at providing confidentiality from either your application layer or your network layer or transport layer? And there's so many security technologies out there. Where do they fit into your environment, and what should you consider where? So if we look at methods of authentication, right, I'm how many of you do not use one-time passwords when you're accessing your infrastructure devices? Higher? All right, so that's probably about half of you. I would very strongly urge you to try and get one-time passwords in place. It's not very difficult to have these systems. One of the things that people always tell me is that they hate carrying around a DES card or some token card. And what I always say is I point to somebody and say, well, take out your wallet, okay? And how many credit cards do you have in there? And I usually say, you know, throw 3 of them away, put a DES card in there, okay? And only keep 1 or 2 credit cards and whatever. Because it's just a matter of carrying a card, and it will make your infrastructure a lot more secure. Now, the assumption, of course, is that you're logging into your infrastructure when you're traveling around to conferences such as this. Okay, and I believe that most people do that. Most people who run network infrastructures do not just sit in their NOC and log in. Okay, you will be somewhere else, probably 50% of the time, and you do not have control of the network that, you know, your data travels across. So I just very strongly believe in, if you can, put in one-time password schemes. Okay, so S-key and token cards are the typical ones that are used. S-key, these slides just show basically how the algorithm works. And most of these technologies I'm going to talk to you about now, they're all RFCs, right? They all come from the IETF. So if you're really interested in more detail, you know, either read that. This is just kind of a synopsis of how they work. So what happens with S-key is you typically have a client, you have a network access server, and you have the S-key server. Both the S-key server and the client are initialized with a shared secret. So what happens is that the client sends an S-key initialization packet, which gets to the server, and the server then says, all right, you know, I'm going to send you a random seed and a sequence number. So what the client then does is it takes the password and the random number and it applies a hash function, typically MD5, and does it 98 times. Okay, because again, 98 was the sequence number that the S-key server sent. And so at the end of that 98 times, it then gets a 6-word output, which it then goes and sends over to the S-key server. Now the S-key server knows that it sent the sequence number of 98, and what it does is it then takes the input that it gets from the client and runs it through the MD5 hash function, and the output of that should match what it has in its database for sequence number 99. Okay, so that's essentially a quickie version of how S-key works. Now, S-key resources, there's a lot of free implementations available. I put a question under Microsoft because I don't know, but you know, I believe that S-key is very, very widely available, and it's something that really a lot of people should look into. So, okay, authentication. Authentication is interesting because there's so many different ways and so many different things that you could use. PPP, all right, I believe that all of you that run any kind of an ISP use PPP authentication, right? You have to. So you could either use PAP, you could use CHAP, you could use MS-CHAP, or EAP. So why would you use one over the other? Well, let's just go through this a little bit. So with PAP authentication, PAP, when PPP was first created, right, it was assumed that people would just dial in via their leased lines and that nobody would be able to sniff the wire. Okay? If you are in an environment where you run ADSL and you might be using PPP over Ethernet, okay, which changes that model, some of your PPP traffic may run over a shared media and people will be able to sniff the wire, right? It's very easy. I mean, just, you know, go to Etherreel, you know, download it right now if you're connected to the network, and, you know, probably takes about 2 minutes to download, click on the icon, and you're sniffing the network. Okay, well, that's for wireless, but on an Ethernet too, it's very easy to get access to Ethernet networks. So with PAP authentication, what happens is that the password is sent in the clear. So you're doing authentication, both the client and the server have a shared secret configured. And what you're doing is that when there's an authentication request, right, you basically send your ID and you send the password, the pre-configured password. The server looks it up in its database, it sees a match, and it says, okay, yep, you know, you're authenticated. But the problem is that nothing's encrypted, nothing's confidential. So you're sending the password in the clear. So I typically recommend that people stay completely away from PAP. Just last night, though, I was talking to somebody and they said, well, you know, people like PAP because you can store the secret in a secure manner. So when I talk about CHAP soon, the way the RFC is written, it basically says that you can't store a secret in an encrypted fashion. But that is very much under controversy. I believe that if you do some pre-processing, then you can. So I would stay away from PAP. I don't like any of my passwords sent over clear text anywhere, because I just think that in this day and age, it's too easy for people to sniff the passwords or some shared secrets. And as the years go by, I tend to trust people less and less. And there's more people, even within a corporate environment, you know, even in your ISPs that, I don't know, I mean, they could just cause too much damage. And so to me, any kind of password sent across a wire really should be encrypted. So with PPP CHAP authentication, the client and server are both configured with a shared secret, just as with PAP. And the shared secret is used as input to a hash function which computes a challenge. And it uses repeated challenges. So during a session, it's a user configurable parameter, but you can send a challenge maybe, I don't know, every 5 minutes, you know, just to make sure that nobody's hijacked the connection. And either of the CHAP peer can act as the initiator of the authentication. So here's sort of a slide that describes that. So if you have some kind of a router that's connecting to a network access server, the first thing that happens is the network access server would send a challenge message, and the challenge message would have an ID. It would have the challenge number, just a random number, and then the name of the remote host. The remote host then would sit there and compute a hash value using a combination of the ID, the challenge number, and the shared secret. It would send a challenge response back, okay, and the challenge response would include the ID, the calculated hash, and then also the name of the network access server. The network access server would then calculate the hash. It would it would compare what it computed to what it got, and if it matches, then it says, yep, okay, you're authenticated, and sends in authentication success. But the point here is that for CHAP authentication, either end can start the initiation, both sides can be authenticated, and you're not sending anything in clear text. So you're not sending any kind of password in clear text across the wire. So there's also, Microsoft came up with its own version of CHAP, and it has 2 versions of it. One of the major things that it did was that it allows you to store the shared secret in an encrypted manner, because the RFC that specifies CHAP, which is 1994, claims that you cannot store the shared secret in the database in an encrypted fashion. It has to be stored in the clear. I have heard from some people that have implemented CHAP as it is, that if you do certain pre-processing, that's actually wrong. Okay. So whatever, I don't know. But if you're implementing either CHAP or you're implementing PAP, understand what you are vulnerable to. Okay, you have to understand, or you have to see how secure your servers are, your database servers. You know, where are they? Who can have access to them? And, you know, how many networks do you traverse going from the network access server, you know, to where you're actually going to the peer? So if it's just one hop away, maybe you trust the network. But if it's 5 hops away, you know, there's more likelihood that somebody can maybe sniff the network. All right. More recently, 4 years, PPP, there's a working group that has come up with an extensible way of doing authentication. Because as our networks have evolved, right, it becomes clear that PAP and CHAP really aren't going to cut it in terms of providing any kind of real good authentication mechanism. And the thought is more towards the future, and hopefully maybe being able to use some kind of a public key technology to provide for authentication. So the Extensible Authentication Protocol, EAP, was created to provide more flexibility for authentication in PPP environments. And so essentially you can negotiate what kind of authentication you use during the authentication process. Because for both PAP and for CHAP, what happens is you create a PPP link connection protocol, and during the link connection protocol you have to define whether or not you use PAP or CHAP, and then you do your network control protocol, and in the beginning of that you actually do your authentication, and the authentication is optional for PPP. And so what ends up happening is that with EAP you don't have to define what the authentication mechanism is when you're doing your link control protocol. All right, so you establish your link, and then you do EAP, and during the EAP phase you then say, oh, you know something, there's a number of packets that go back and forth, so you request and responses, and basically without those packet exchanges you then decide on which authentication you want to use. Do you want to use a one-time password? Do you want to use CHAP? Do you want to use Kerberos authentication? I mean, there's a whole slew that are being defined. And so as new authentication mechanisms evolve, then EAP can handle that. Okay, so more and more people, more and more devices, when they're implementing PPP and doing some kind of authentication, they are using EAP because it gives you a lot more flexibility. So essentially, here's a picture that shows how this would work. And once the PPP link is established between the telecommuter and the network access server, the network access server would then say, okay, you know, I need some credentials from you, telecommuter, you know, and it sends an EAP request. The telecommuter would then send an EAP response, which gets forwarded to the EAP server. Typically, this would be a Radius server, maybe a TACAX Plus server as well, but a lot of times Radius is used. The EAP server then would send an EAP request, which basically gives the mechanism that it wants to use and forwards it to the telecommuter. The telecommuter would then respond with the information, the credential that the server needs. The server would verify, and then, you know, the telecommuter would get authenticated. So essentially, the network access server then just becomes a pass-through. And what's nice about EAP too is that if, for instance, you are using a one-time password today for your authentication, but you want to use digital certificates maybe 5 years down the line, 3 years down the line, you do not have to change any software on the network access server per se, right? You can just do it with the EAP server or the Radius server. So that's a pretty cool thing. So just as a summary for PPP authentication, in PAP the password is sent in the clear, and in my personal opinion it should be avoided. In PPP CHAP the passwords are at least encrypted, and then PPP EAP is the most flexible, and I think in today's networks, if you're figuring out or trying to decide on what authentication to use, PPP EAP is really the way to go. So, all these authentication mechanisms, all right, So what do? I mean, you're going to have large networks and you need some kind of scalability, right? I mean, you're not going to sit there and configure on every single device these shared secrets. So most of these technologies that I was discussing with PPP, like your PAP, your CHAP, your EAP, they end up being used in conjunction with some scalable protocols like TACAX Plus or Radius, which provide, in addition to the authentication piece, also access control and accounting. And then there's also Kerberos. So just to get a feel for it, because I know, I mean, as I give these talks, you know, it's like people who understand it, you know, they might look at one piece or another. Other people who've never seen it, you know, their eyes get glazed over because there's just way too much information to process. So I am not going to go over this in detail because the primary thing that I really want to focus on anyway is just, all right, you guys are going to be architecting your networks. Some of you have already put security stuff in place. And what is the most relevant in your environments? What are the 5 most important things that you should be thinking about? And then giving you some, you know, configuration examples. So these particular slides, I mean, remember I give this talk and it's usually a couple of days or a week long. But you will have this, right? You will be able to see this in your slides. If you are interested in how this works, this is very much a synopsis, okay? And if you're even more interested, then, you know, you might want to read through the RFCs, but who has time for that? So I'm just giving you some quickie, like crib notes in terms of what's important when you look at authentication. For TACAX Plus, the thing to keep in mind is that the transactions between a TACAX Plus client and a TACAX Plus server are encrypted. Okay, it's confidential. So if I'm sniffing the wire between a TACAX Plus client and a TACAX Plus server, I will not be able to understand what it is just by sniffing the wire. And if anybody's interested in sort of what algorithm is used, that's right there. So it's a combination of a hash function and the XOR function. TACAX Plus header, I don't know, just put that in there because sometimes people are interested if they're, you know, trying to debug something, that's what the header looks like. So the exchange. The main reason that I have this picture in the exchange or regarding the exchange is because there's a misnomer sometimes that what the user sends to the network access server is encrypted. It is not, okay? So what is encrypted and how TACAX Plus works is that the network access server is the TACAX Plus client, and then it talks to the TACAX Plus server. That communication is encrypted. But what the user sends to the network access server is most likely not encrypted. Okay, so if you're using CHAP or using PAP or you know, you're trying to ascertain what kind of a password to get, it could be sent in the clear. And so if you're connecting a user to the network access server, be very clear in whether or not you understand whether or not somebody could have access to the information that's traversing the wire. Okay, so when we're talking TACAX Plus and we're talking about, you know, encrypted confidential transactions, it's between the TACAX Plus client, which is the network access server, and the TACAX Plus server. Okay, so the transactions or the information being sent from the user to the network access server is going to be in the clear. So Radius is very much like TACAX Plus, right? They're more or less synonymous. I mean, there are some differences. Again, TACAX Plus was basically Cisco trying to, you know, get market share. I mean, they did add some value to it, but I think in this day and age, most people will use Radius. It's more widely available. There's a lot of freeware versions available. And, you know, even Cisco at this day and age is not pushing TACAX Plus. They're just saying, you know, whichever one you want to use. So the major difference with Radius and TACAX Plus is that within Radius, You have the same kind of client and server model where the network access server is the Radius client, but the transactions are not completely encrypted, only the password is encrypted. So whatever the user credential is, okay, that is encrypted between the Radius client and the Radius server. So the transaction looks basically the same, or how the authentication is carried out. And again, the same kind of consideration here, where the password that's encrypted, okay, it's from the Radius client to the Radius server. So the Radius client being the network access server. So whatever you're sending from the telecommuter or the user going to the network access server may or may not be encrypted. Most likely it's not. So as a comparison, TACOX Plus, uses TCP, so it uses a more reliable transport. Radius uses UDP, and it's supposed to use UDP port 1812. Some older versions use the other port, 1645, just an FYI. Only the password is confidential in Radius, and when people ask, well, which one should I use, right, I think the answer comes down to more of a, well, what features are supported, and what is the vendor support like? So I think those are the most important things in terms of what are the attributes that are supported, and if you have a variety of different equipment, or you're using an NT environment, and money comes into play. So the trade-offs are, I don't know, it's really one or the other. And I think most people do end up using Radius simply because it's a little cheaper and it's a viable option. All right, another question here, because there's so much material I need to find out so I can figure out what to kind of skip. How many of you are in a Kerberos environment? Considering, how many of you are considering Kerberos? Okay, I'm going to skip over these slides. How many of you want to know about Kerberos? All right, I won't completely skip over them. But I'll go over them fast. You won't understand, if you don't know about these technologies, I can't teach them to you in 5 minutes or, even 10 minutes. Again, if you are more interested in some of this and it's new to you, or you have some questions, I'll be here till Wednesday morning, right? So we can sit down and, I don't know, if I can provide you with some information, great. I actually really like security. So anyway, so just as a caveat, so if you're wondering why, oh shoot, she was going too quick, I want to know more, it's really hard when you have so many different levels to really get everybody, to please everybody completely. So grab me later. Okay, Kerberos, it was designed by MIT. Major point is it uses a trusted third party to issue tickets to users. All right, I think most of us actually sort of know that. So Kerberos. Kerberos relies also, it relies on a shared key. So you have a KDC, which is a key distribution center, okay, and that's the trusted third entity in Kerberos. And you configure keys, so shared keys. So you configure a shared key between the KDC and the client, and you then configure another shared key between the application server and the KDC. So those would be K client and K server respectively. So the KDC has this whole database of principals, which is basically entities that it has shared keys with, and their associated keys and also access rights. So what are they allowed to do? So what ends up happening for a Kerberos authentication is that the client sends an authentication request. The key distribution center, the trusted third-party server, verifies the client access rights, like is it even allowed to do, what it wants to do. And it sends some kind of an authentication response, which starts the whole process, where it sends a session key, a random number and server name, and these are all encrypted with the client key. And it also sends a Kerberos ticket, a ticket that's encrypted with the server key. And then what the client does, it prompts the user for the password, right? So whoever's sitting at the client. And it uses that key to then decrypt the session key. So now we have a session key, okay, that both the client and the server have. And now you're trying to, authenticate the application. So the client then sends an application request, which is the Kerberos ticket encrypted with the server key. And it also sends an authenticator, which is sort of a token, encrypted with the session key. The server decrypts the Kerberos ticket to get the session key, which is then used to decrypt the authenticator. And I see a lot of eyeballs just going, huh? Yes, this is very confusing. So, you're going to have to spend a little bit of time probably to just kind of mull over this. And I'm just reading off the slides because I don't know how else to do it right now. But essentially what happens is there's a number of transactions that happen. You have shared keys between the client and the trusted third party. You have a shared key between the trusted third party and the application server. And there's a number of transactions that happen back and forth, and how it's encrypted and how somebody gets the key. And the end result is that you end up having this ticket, okay, which is basically a string of bits that as you're sending it back and forth between your application server and yourself, you can verify that you are who you say you are and that you are allowed to do what you think you're allowed to do. And for example, if you want to do Kerberos authentication for accessing a network device, right? So the network device then will have to have some Kerberos software on it. You have to run Kerberos on your client, and then there's another Kerberos server, of course, the trusted entity, and then the transactions happen in place so that you as a client end up with a string of bits that when you're sending your telnet packet to, let's say, the router, that then the router can verify that, yes, it is actually you and you are allowed to telnet to the router. All right. And it is complex, right? I mean, that's why the RFC is so big. But mathematically, it's fairly sound. The one thing that you need to know in a Kerberos environment is that it's very dependent upon timestamps. And the thing with timestamps, and it's something that, it's a simple concept, but it's amazing how many people just, it kind of falls through the cracks. It's, you want to make sure that you have consistent timestamps throughout your network. And I ran into this. I mean, I have a very small network at home. I mean, I do have about 5 or 6 routers, and I have probably 2 servers and maybe 5 hosts, because I play with stuff. I want to understand all the security stuff with all these things. And I started, just configuring syslog. And I have a Unix machine, and I have my router. And then, I'm just like, oh, cool, I've configured logging, right? And about a week later, I started looking at these logs, and I'm like, huh? I got all confused. And I realized the reason why was because I hadn't set up NTP on my Unix server. I just used whatever the system time was on there. Or I had used something else, and it was off by about a minute, And I mean, trying to actually figure out, it took me about a day to realize what I had done. I can't remember now what it was like 2 years ago. But it was off by 1 minute. Now, if you're doing some kind of forensics later, and you're trying to figure out what happened, a minute is a very, very long time. Okay, so it's extremely critical that you configure your timestamps on all of your devices that you are going to require to have logging capabilities, and make sure that they're all synced up. Okay, extremely important. And, again, it might seem like a simple point, but I've run across a lot of people who are like, oh yeah, shoot, and they go and verify, and then, they put in the commands for the NTP servers. But, check your logs, make sure that they sync up. And with Kerberos, it's very important to have synchronized and dependable mechanisms, because Kerberos very much depends on timestamps. So, all right. Now when we talk about real networks again, okay, cool, so you're authenticated. Well, so what? Right? So I'm sitting at home and I want to access my network infrastructure because for some reason I need to change an access list or a filter somewhere. So the thing is, if I authenticate, can I then have access to absolutely everything? Well, that used to be the case. I believe now people are getting much, much more stricter in terms of what kind of access rights people can have to various parts of their network. And unfortunately, I think it's going to grow worse, because it used to be that, networks were all open and, everybody thought it was really cool. Now that it's become a business and there's a lot of money involved, we basically have to restrict access. And so, okay, so if you authenticate, how can you then control access to what people have access to? Well, here comes IEEE 802.1x. And, people have been doing proprietary things for a number of years. Now there's actually a standard way to, first of all, authenticate somebody, and then to give them privileges to access certain parts of the network. So 802.1x has three entities defined. One is a supplicant, one is an authenticator, and one is an authentication server. Just, three terms. And basically, what the supplicant can do is it can gain access to the authenticator. The authenticator will only allow traffic to go to the authentication server. The traffic can't go anywhere else, and only once the supplicant is authenticated can the authentication server then define the access controls as to, okay, what areas of the network can you actually have access to. So I hate the term supplicant. I don't know. To me, it's always so confusing. A supplicant is simply, my host. Okay? My host that's trying to gain access to the network. So, and 802.1x is, again, it's new, forward-thinking. So you use the extensible authentication protocol for your authentication because you want the flexibility, right? You might want to use one-time passwords today, and you might want to use public key cryptography, 6 months from now. So here's sort of an example of how this works. And since I don't wear watches anymore, what time is it?
20 to 3.
20 to 3. Okay, cool. Thank you. So 802.1x. So here's what happens. Supplicant, i.e. workstation. And then you have the authenticator, which is typically a workgroup switch. And then you have some kind of a server, which more or less is a radius server. So, all right, what happens? So when the workstation connects to the switch port, okay, it's only enabled for a certain defined traffic, which the acronym is EPOL. And I forget what it stands for. Something like Ethernet Access, something, something, something. Okay. Basically, it's a protocol that says, something, the only traffic that's allowed is this EPOL traffic. And so the workstation then sends an initial authentication packet exchange using this protocol, right? So a certain bit in a packet that says, hey, I'm EPOL. So the LAN switch then gets that packet, and the switch translates between the EPOL messages and the EAP radius server messages, and it's just a pass-through, right? So the workstation now talks to the radius server, and they carry out the authentication exchange. And, again, EAP is basically just a bunch of request and response packets. The first one says, hey, I want to use one-time password. And then the response is like, okay, well, here's a challenge and blah, blah, blah. And then they send whatever credentials they need back and forth. So whatever authentication mechanism you use, you just kind of request, hey, I want to use this authentication mechanism, and then you transfer the credential information back and forth, and you hopefully have a successful authentication. And then once you have a successful authentication, because you're typically using a radius server, you can then define your access control as to, all right, this guy is now authenticated, and here's the access control rights that particular workstation has. Okay, so I believe that people are not really going to allow access control all over the place to their network. And this gives you a lot of flexibility so that if you have different kind of customers with different requirements, right, you don't have to worry so much about doing other convoluted things, but you can use this mechanism to then give the access control rights to only certain places. So I think it's a very powerful thing, and you really should think about it. And one of the things that I've also thought about, I mean, with all this stuff with the viruses and worms, I have become a very strong proponent of, if you at all can do this, right, and especially if you're an ISP that has a lot of customers that really will not be very knowledgeable about any kind of virus checking or upgrading their software. Okay, I mean, the environments vary so much in terms of what you guys as ISPs do, but if you have any kind of control at all, what I like about 802.1x, that used in a conjunction with maybe being able to have some kind of control of your customers' machines and having them go through some kind of a virus check, and then maybe pointing them to a particular area of the network if they fail, so that they can then download whatever appropriate version of software you think, and you've tested in your environment for your customers, that this could be a very interesting thing to do in the future. Because the biggest problem we right now have in terms of security is really the proliferation of viruses and network downtime. And it's getting a lot worse. And I used to be somebody that said nobody's ever going to touch my machine and have control over it. But as I look around, it's causing a lot of detriment in terms of ISP networks, and the issue is just getting worse and worse. That people have to be re-educated, and I do think there needs to be more control, especially from ISPs. And again, that's very controversial, but I'm just going to put that out there. All right, so authentication technologies, right? I mean, there's tons of them. Everybody uses probably bits and pieces of everything that I've discussed, and they always will, okay, because no technology ever goes away. Then again, ChaosNet went away, didn't it? So you never know. But as an authentication, as a summary, I am a very strong proponent that use one-time passwords whenever possible. Come up to me with whatever excuse you have, and I will probably have an answer to mitigate that, hopefully. But seriously, try to do one-time passwords. It's really the securest way to go. PPP-EAP with Radius. Okay, if you're using PPP environments, that is really something you should very strongly consider. And AAA solutions, again, Radius or TACAX Plus, can be used with most authentication functions. And 802.1x will replace proprietary port authentication features. Right, so 802.1x is something to really look at. And of course, if you have a multi-vendor environment, understand what some of the interesting features and functionalities are, where they may or may not be interoperable. But that's other discussion. All right, application layer security. SHTTP, SMIME are two ones that usually come to mind. A lot of people don't use SHTTP because a lot of people use SSL, which I will describe in a little bit. SMIME, the reason I want to bring this up is because for people that are considering voice over IP networks, for authentication, SMIME is part of the standard. It used to be PGP, they got rid of that, so SMIME will become important, and you should understand that. SMIME provides these security services, so authentication, message integrity, basically verifying or validating that nobody has messed with your message while it's going from, let's say, caller to a receiver, and origin authentication, and also privacy and data security. So it provides the services, but you don't have to use all of them. It is up to the implementation to decide whether or not to digitally sign a message first or encrypt it. Okay, and there's of course various trade-offs. So if you first sign a message and you provide the integrity for it, and then you encrypt it, you will always have to decrypt it before you can verify maybe who the caller was or the initiating party, right? So there's trade-offs. It's implementation specific, which, you know, I always hate, because that means that there's all these issues with trying to figure out what's interoperable and who's doing what, and if you're in a multi-vendor environment, it gets interesting. So SMIME, the reason why it's really, really important to understand it is more or less if you have, or thinking of voice over IP networks. Transport layer security, all right. SSL, TLS, long history. Basically the top sentence, I mean, it provides data encryption, server authentication, message integrity, and an optional client authentication for TCP/IP connections. Basically, it uses the TCP transport, so you know you're not going to be authenticating UDP. And what SSH does, SSL, sorry. Essentially, you have an SSL client and an SSL server. And the client will initiate the SSL connection and send a supported set of cipher suites. Now, cipher suites are essentially, okay, what algorithm do I use for confidentiality? What algorithm do I use for data origin authentication? And some of the first slides that I had, remember that your encryption, right, you basically use something like DES or AES or triple DES. So you pick one of them, right, or for a message origin authentication, you might use some kind of a hash function. So do you use MD5, do you use SHA-1? So in the first initial message, you send basically what you propose as, all right, this is the algorithm that I want to use for confidentiality encryption. This is the algorithm that I want for data origin authentication, blah, blah, blah. The server then selects a cipher suite and returns its digital certificate to the client. And the client sends an encrypted shared secret back. So what now happens is that the message encryption and data integrity algorithms are negotiated. So you now have a secure tunnel to negotiate your message encryption and integrity algorithms. You create session keys, and then the data is sent over, you know, the secure tunnel with the parameters you've negotiated. Now, the important thing about SSL is that client authentication is optional. And what a lot of implementations do is, because public key infrastructures really do not exist very much, somebody always tells me, well, we use one, and then last night somebody goes, well, we have one, but, well, it's not really that public. I'm like, okay, well, you know. So what people do is, for client authentication, they usually have some proprietary client authentication mechanisms. And what happens is they do it after the secure tunnel is established for SSL. So actually the client authentication, the credential material traverses over the secure tunnel. So if you look at transport layer security, there's a lot of people that talk about, you know, how to create VPNs. Do I use IPsec? Do I use, you know, SSL, TLS? In the second part of the session, I talk about sort of architectures and things that you have to think about. For anything that deals with the transport, essentially you're going to be poking a hole through the firewall, right? Because firewalls typically look at layer 3 traffic, right? And you look at, you know, your port numbers, your addresses, and you don't look any deeper. You don't look at the transport layer per se. And well, no, you do. Anyway, but if you do SSL or TLS, you end up more or less poking a hole in the firewall and then ensuring that the traffic will go to its end destination, right, whatever its application is. And I think that SSL or TLS and IPsec work in conjunction with each other, but later on I will point out that if you do encryption or authentication at the network layer, you have a little bit more flexibility. Yes?
That third line, that put at the top, or that one again,
I don't know offhand. It could be POP. I think I actually looked at the RFC numbers, so, or at the IANA numbers. So the SMT it should be 25, probably?
SMT is 25, and POP is, POP 3 is 110.
Okay. You could be right.
But I don't know what the 995 is.
Yeah. You know something? I don't know them offhand on the top of my head. So, but you could be right. So basically what this slide points out is that there's a defined port number for these protocols, either your mail server or FTP or whatever. And then if you're using TLS or SSL to secure them, then there's a different port number that's defined by IANA. I'll check on that. All right, SSH, I'm not going to go through this. What SSH is, essentially, it's a mechanism to, people use it to access your devices. It's a low-level transport protocol, and it encrypts traffic. So if you're on a device, let's say your laptop here, and you're trying to connect back to some device somewhere else, rather than having all the information sent in clear text where somebody can actually view it, you know, I mean, everybody's using wireless here, rather than sending the information in the clear, you can be fairly assured that, you know, well, nobody's going to be able to, nobody, if they're actually sniffing the wireless network, will, without doing more work, be able to compromise your devices. And you know, I have to be careful what I say because, of course, you know, you can get the encrypted data, and depending on what other computers and whatever else you have, you might be able to crack whatever scheme there is. But for the very silly little attacks where, you know, it's very easy for somebody to sniff the wire and see the password, if you use SSH, it keeps your information much more confidential. And, you know, people have to do a lot more work to actually try and compromise your systems. So SSH, you should, if at all possible, always use SSH to access your devices. Telnet is very, very bad. People should not be using it anymore. The only caveat being that, you know, sometimes there's bugs in devices, and what some people do is they actually do SSH to certain hosts within their networks, and then from that trusted host, they then telnet to whatever device, right? But if at all possible, use SSH. So, okay, IPsec. How many of you are using IPsec currently? How many of you are using IPsec to authenticate your routing updates? Okay. How many of you are using IPsec for confidentiality? So that means that most of you are using IPsec for authentication, so data origin authentication. How many of you are using IPsec only for data origin authentication? All right, I'm confused. Okay, unless I'm asking the wrong questions. But so most of you raised your hands to say that you're using IPsec. So IPsec can be used for either origin authentication, data integrity, right, same thing, or for data confidentiality, or for both. So most of you are using IPsec, but none of you raised your hands for integrity or confidentiality. So what are you doing? So I'm curious, somebody, you know. So all right, let me ask the question again. How many of you have configured and are using and are sending traffic between your devices using IPsec? Nobody. Okay. All right. Okay. All right. So we're going to talk about IPsec because maybe somebody will at some point use it. You know, a lot of people spent a lot of time in these meetings to define this god-awful standard. And, well, I will tell you my perspective, okay, because I'm up here and I can, is that the thing that I think is the problem with IPsec is quite frankly vendors. And I think that what vendors need to do is that they need to simply have these configuration things that tell users that, do you want to use IPsec Do you want to have data integrity? Do you want to have confidentiality? And then one more thing that they need to ask is, how do you want to authenticate? Because you have to figure out whether or not you're going to do pre-shared keys, which is a shared secret, whether or not you're using digital signatures like RSA signatures, or whether or not you have a public key infrastructure. And that's it. You know, I don't understand this garbage about mod P groups. You know, who knows what a mod P group is? Yeah, you do. Well, what mod P group is, it's a Diffie-Hellman group. So you have to know the IPsec standard to configure IPsec in your devices. I don't get it. And then, you know, I've talked to a bunch of the engineers, and the reply that I used to get was, well, I don't want to define somebody's security policy. I'm like, default. You know, it's changeable. So I've been wanting for these smart security engineers to get together, define the defaults, have all the vendors implement the same algorithm and stuff for the default, so that for the users, they just have to enter 3 commands and you're done. Okay, so I think there's a big conspiracy theory going on. But people are working on it. It is getting easier. And I will actually try and explain IPsec in a way that hopefully it becomes a little more clear. Because again, I think a big issue with IPsec also is there's very confusing terminology. And you know, I've spent a long time really trying to think about why is it so confusing. And you know, people interchange terminology, and two terms mean the same thing, right? And I think that all adds to the confusion. Yes? Oh, I have 2 minutes. Okay. Thank you. Okay, let me ask a question. Another question, sorry, but security, really, there's so much to know, and I really try to at least get a lot of the basics down, because something that I learned very early on in my security career or networking career is, how do you ask the right questions? You know, so rather than just sit there and give you a bunch of templates, which you're going to have anyway in these slides once they're up on the web, you know, and that's easy. You can just look at them and say, oh, okay, well, this looks cool, I'll configure this. I very much want people to kind of go away with a thinking process of, oh, okay, this is what I need to think about, okay, because people don't talk about that. And I think that's the hard part with security, because there's always trade-offs. There's so many trade-offs. And just as you have trade-offs when you're actually just architecting your network, like do I use Ethernet or token ring or FTDI or ATM or whatever, security, because there's so much to consider, there's many more trade-offs to consider. And I think that's what makes security so hard, is because you have to spend a lot of time talking about the trade-offs. Anyway, so what I would like to do is I would like to break. What I would like to do is spend maybe the first 15 minutes when we come back, if you guys come back or whoever's here, talking and trying to simplify what IPsec actually is and what the relevant parts are. Because then as I go over how you actually configure it in different devices, it might become easier to understand how you configure it. So rather than go through that. And then I will very quickly go over what L2TP is, and then I will start in on, okay, so here's all this slew of technologies, and when you're architecting your network, what are the things that you need to do to actually, you know, do secure routing, you know, have device security? What are the things you need to think about when filtering and to do some kind of auditing? So I think I'll break now, you know, let your brains regroup for about half an hour and then come back. Thank you.